We're going to set up your first task. Your first task is
Mr. Mac, we have some people.
you have function f of x.
We got some people.
We've got two functions, f of x and g of x. And you've got tables. You're going to fill out the tables, and then you're going to plot the points on this graph, both on the same graph, and you're going to compare things. Now, just looking at the straight up functions before you even get started, what appears to be the difference of the functions?
A one's plus 4, one's a minus.
So one has a plus 4, one has a minus 4, so we must be thinking, what does that have to do with where it is, right? Also, let's take a note. What form are these in? Factored or standard? Factored form. So we already know before we do anything, what's factored form really good for finding? X-intercepts in particular. So just have all that in mind. Run through the tables, graph your two functions, and then make some observations, and then I'll put a bow on it at the end. Now, one thing I'll let you know, the calculator will slow you down. This is much quicker without the calculator. So you're going to want to grab the calculator. I know it's like your little teddy bear, like, oh, calculator, you make me feel so warm and fuzzy. But it's going to slow you down, so try not to calculator it up. So, roll through these with me. I like to do something like this to make my eyes go to the function I'm using. So for f of x, so when x is negative 4, I've got negative 4 times 0, which is 0. When x is negative 3, I got negative 3 times 1, which is
Negative 3.
when x is 0, I got 0 times 4, which is 0. When x is 1, I got 1 times 5. When x is 2, I got 2 times 6.
12.
When x is 3, I got 7 times 3.
21.
When x is 5, I got 9 times 5.
45.
45. We all good?
Yes.
Input, output. Put x in, get y out. Okay. I'm going to get another color over here for g of x. Input negative 4 for x. My eyes are going here now to this function. Negative 4 times negative 8. 32. Negative 3 times negative 7. 21. 0 times negative 4. 0. 1 times negative 3. Negative 3. 2 times negative 2. Okay, 4 times 0. And 5 times 1. How did I get negative 6? I could have messed up. So 2 times negative 2 is negative 4.
Yes.
So I don't know how I got that.
Same thing. Oh my God.
Okay. I'm going to choose next to plot the points before I do, just so we have the visual to match the vertex and stuff. So we're going to plot the points for the first one, which means we're graphing a parabola. All right. I'm not going to plot all of them, though. I got negative 5, 5 right there. I know I got a 0, 0. I know I've got a negative 2, negative 4. Where's my other 0? I got negative 4, 0. That's all I'm going to choose to plot for this one. But it looks something like this if you plot them all, right? Y'all good? If you plot them all, it looks something like that, right? Okay? So it looks like plus 4 shifted me which direction?
The other way.
Left, right? Looks like plus 4 shifted me left of the y-axis. Let's see. So in theory, a minus 4, in theory, we're thinking might shift us which direction then?
To the right.
Well, that's the only one way to find out. That was true with the absolute value, wasn't it?
Yeah.
So I got
Same shape.
I've got a 5, 5. I've got a 4, 0. I've got a 2, negative 4. Okay, that's enough points for me to graph what I need you to see. So it kind of looks like the same thing, only different. It's to the right instead of to the left, right? Take it back, y'all. No, y'all. So it looks like that plus and minus 4 is shifting us left and right, doesn't it? Kind of looks like that. So let's start writing our stuff like our x-intercepts. So our x-intercepts for f of x were negative 4, 0 and 0, 0. And what was our vertex? Negative 2, negative 4?
Yeah.
Okay. And then for the blue, our x-intercepts were 0, 0 and 4, 0. And our vertex was 2, negative 4. Sweet. Now, I want you to come up with some kind of rule for our vertex. Okay, the vertex is what our next focus is going to be. Now, notice the vertex goes through this imaginary line. I've said what this line is before, but maybe you don't remember. I call it the axis of symmetry. You can imagine folding your parabola on that line and its mirror image, right? So I'm going to let you know this. There's a relationship between your zeros and your axis of symmetry, and I'm going to give you 30 seconds with your partner to try to summarize that relationship. Hey, y'all. I heard at least 3 really good explanations of this axis of symmetry. Okay? I'm going to summarize them for the sake of time. Essentially, at least 3, maybe more groups, but listening around, they noticed that the axis of symmetry is halfway between the zeros. Troy alluded to it in the warm-up with that y-axis thing.
Troy was already on.
Well, Troy was like, the y-axis isn't going through the middle, kind of like the reverse of it, right? So would you guys agree every parabola we've seen, that axis of symmetry goes right through the middle, which means it splits the zeros. Exactly splits them, right? So if I have a 0, 0, and a 4, 0, the axis of symmetry has to go through 2. If I have a 0, 0, and a negative 4, 0, it has to go through negative 2. Now, the next step we need to consider is, how do we find the y value if we don't know? Like, we had this table, right? And it happened to be on our table right here and right here. It was on our table. But if we don't know that, let's say I know that x, let's just look at the blue one. I knew that here, halfway between 0, 0, and 4, 0, x had to equal 2. Is there a way to find y if I know that x is 2?
Yeah. Yes.
Yeah, what do I do with it? We plug it into the function.
Yeah.
So, if I'm looking at the blue one, it goes in here and here. 2 times negative 2 is negative 4. There's your vertex.
Oh.
We know we get an output from an input. We now know, you knew the axis of symmetry goes through the middle. We know zeros. Nothing new. Collection of knowledge to have a new knowledge. Woo! Still going to kind of baby step there, but notice, if a lot of things to do, but if we go based on like general understanding and concept, those things to do come to us from concept. So I want us to do an x-intercept, an x-coordinate, and then I'm adding something to this. I want y-coordinate of the vertex. It's like the axis of symmetry would tell you left or right. How far left or right is your vertex of the origin? Yep. We're going to skip number 2 because you won't need that to confirm, because I'm going to confirm. So, as we look for the x-intercepts, if this x is negative 3, it works. And if this x is 5, it works. Because if we can get it to equal 0, that's the x-intercept. So, the next part for the x-coordinate, how far away are negative 3 and 5 from each other? 8 away, which means the middle has to be 4 away. So I don't care if you look 4 more than negative 3 or 4 less than 5. That means the x-coordinate has to be 1. And when x is 1, so put a 1 in for x. When x is 1, I got a 4 times negative 4 for a y-coordinate of negative 16. So now I know my vertex. My vertex is 1, negative 16. Sick, huh? Next, to get this to equal 0, x can be 0, or x can be 3. What's halfway between 0 and 3?
1.5.
And if I slap 1.5 in for x,
You get 1.5.
I get a negative 1.5 times 3.5. What is that? I need a calculator. It's 5th hour. Do it. Yeah, let's do it, Sean. We need a 3.5. Wait, no, sorry, 3 times negative 1.5. What is that, negative 4.5?
Yep, negative 4.5.
Oh, I could have done it. So there's my y-coordinate. And lastly, I know I need a y-intercept of negative 4 and positive 4. And what splits those?
8.
They're 8 apart. So how far away from? So it needs to be in the middle. It needs to be 4 away. 4 more, 4 less, 4. X-coordinate is 0. And when x is 0, 0 plus 4 is 4. 4 minus 0 is 4. What's 4 times 4? 16. That is my vertex. So big picture. Big picture. I know my x-intercepts because it's when y is 0. I know the x value of my vertex because it is in the middle. And then I can find my y value because I can plug in my x value. I want you to sketch the graph for number 3, please. Let's go over everything we know. No, Cam, hit me with those x-intercepts. For that?
7.
7, yep, I got a 7, 0. Okay, what's the other one?
-11.
Yep, negative, I don't know why that's funny. Whoa. But I got negative 11 for the other. Okay? There's a 7, there's a negative 11. Okay, next I need to get the vertex. So I need to know the middle. I need to split these. What do you got, Sean?
Oh, I got -2 for the middle.
-2. So I'm going to just go, I'm going to put that imaginary dashed line here, okay? And I know my x has to be -2 because -11 and 7 are 18 apart. Halfway between is 9 away. 9 less than 7 or 9 more than -11 is -2. Now, once I know that, how am I going to get my y value?
You plug it in.
Plug it in.
So put a -2 up in here. So I get -9 times 9, which is
-81.
-81. So somewhere down there, right? Something like this. You've got a scale. You've got a scale on yours. So let's review all the big picture things. We can get x-intercepts or x-intercepts by getting y to be 0. That's how we did these. We can get this axis of symmetry by going right in the middle of those. And we can get the y value of our vertex by putting in our x value of our vertex into our function. It's pretty sweet. The only new thing today is the middle, but we kind of already knew that anyway.